Now we already know how to apply KCL and KVL, the loop rule and the node rule. We have already know how to use that in simple circuits. So here we'll deal with slightly complicated circuits which have batteries. So students become confused when there are many batteries in the circuit and they try to do something different with these batteries, and that is the problem. We don't do anything special with these batteries. We just follow our step-by-step process and solve for the currents as we have always done in the other circuits also. In this case also we use the same method and we will get the correct answer. Okay, so the thing here is we start when we apply the KCL and KVL, we start by trying to simplify the circuit. See if this circuit can be simplified by using the series or parallel combination of resistors. Of course, I have made sure that that cannot happen here. So we go to the step 2 of solving the problem, which is again very simple. We try to assign the currents. We give the currents directions and we try to give them variable names, which is in this case I have done I1 is equal to I2 plus I3. Okay, so I have given the three names, three currents here I have assigned, and I have chosen these two loops as the loops I would use to apply my voltage law. Of course, you can choose the loops differently, you can assign currents differently. Okay, that shouldn't change the answer. The direction you can choose differently, direction of the currents, that again shouldn't change the answer. Okay, so the very first thing is that according to the KCL or the current law, we can clearly write that I1 minus I2 minus I3 is equal to 0, or in other words I can write I1 is equal to I2 plus I3, which is simple because I1 is current coming in, I2 and I3 are current going out. Those two, the sum of the currents coming in should be equal to sum of the currents going out. That's what the other way of doing the KCL. There should not be any current loss or gain, if you will. Now I apply the KVL, the voltage law or the loop rule to this one, to the first loop right here. Okay, and this is the second loop, and from this I will try to get an equation. So that would be my next equation. I have three currents to solve for, so I need three equations. That is understood. So now the first we traverse the 6 ohm resistance, so this becomes minus 6 I1. Then we go here and we go to the loop where current I2 is flowing, and it's I2 everywhere. Okay, the next thing that we encounter is this battery. We are going from minus to plus, which is a voltage gain, so we write plus 14. Then of course we traverse the 4 ohm resistance in the direction of current, so we write minus 4 I2. And then again we encounter this battery. Again we go from negative to positive terminal, we are going this way, and this becomes a plus 10, and this is equal to 0. So we try to simplify this equation right then and there. We'll just do it right here, and what happens is that this becomes 6 I1 plus 4 I2. Okay, I change the sign also, and this becomes 24. We simplify it further. We try to divide the all the terms by 2, and this becomes 3 I1 plus 2 I2 will be equal to 12. Okay, nothing complicated, very simple. Okay, now we move on to our third equation, which will come right here, and this will be because of this loop. So again we traverse the 6 ohm resistance in the direction of current, so again there is a drop, so it's 6 I1. Okay, and solve this numerical with me. Take a pen and paper and solve it with me. You'll understand how we are doing things, and that will be a big help when you are doing numericals on your own. And this becomes minus 2 I3. Again we are going in the direction of current, so this becomes negative, and then we come here, which is a voltage gain. If you go, we are going like this, right? So this is minus 2 plus, so this becomes plus 10, and this is equal to 0. Again very simple, nothing complicated. We are doing things very simply here. So this again becomes 3 I1. Okay, so we'll try to divide everything by 2 again and change the signs a little bit. So this becomes plus I3 is equal to 5. Okay, so now we'll name the equations. Okay, so you can choose to name the equations. it is better if you do initially. Okay, later on you can catch the speed, but initially if you are doing things slowly but accurately, that will help you build the confidence. You'll be getting correct answers one by one, all answers are correct, and slowly you will gain confidence, and then you can increase your speed. The speed will come automatically with practice. Okay, but when you are doing it for the first few times, take it slowly. Okay, don't be in a rush. Not every question has to be solved in under 1 minute. If you're doing step by step, under 1 minute, you will come there with practice. But accuracy is most important to gain the required confidence. Okay, that is what we are doing. We are doing it step by step here. So just do it with me. Okay, so now we subtract equation 2 from 3. So that's what the next step will be. We will just be doing this subtraction. Okay, we'll just use a different color. Okay, so 2 minus 3. That's what we are doing. Equation 2 minus equation 3. So 3i1 get cancelled. This 2i2 will come. So that is something we do expect here. So this 2i2, and of course minus i3 will come. That is to be expected as well, because this is subtraction. So minus i3 will come. This minus plus will become minus, is equal to 12 minus 5, which is equal to 7. Okay. So now what do you see? You see that we have some equations. We have eliminated i1 from here. So from here I can, if I want, I can get the value of i3. That looks to be the simple thing here. Without getting any difficult fractions, we can simply get the value of i3 from here. That looks simple. So I take i3 that side and I bring 7 on this side. That's what I'm doing. So i3 goes there, and this becomes 2i2 minus 7. Okay, this plus will become minus 7. Okay, this is a 7. So now I use this i3 in our equation number 1. So we call it 4, and I do a substitution of 4 is being substituted in 1. That is our next step. That's what I'm trying to do next. 4 I am substituting in 1. So again we'll choose a different color. Okay, so now 4 is basically telling me i3. So I can write i1 is equal to i2 plus 2i2 minus 7. That is what the value of i3 is from here. Okay, very simple, nothing difficult. So this becomes 3i2 minus 7. So now I have i1 in i1 I have in terms of i2. So what is other equation between i1 and i2? This is the other equation between i1 and i2. So I can simply do this replacement. Okay, so I do this substitution. So this is equation number 5. So we substitute equation number 5 in equation number 2. That's what we are doing next. Okay, and again very simple. We are not doing anything complicated. It is very simple only. So this is 3 3s are 9i2 minus 7 3s are 21, and this is plus 2i2 is from that equation only, is equal to 12. Simple. Now this becomes 11i2 is equal to 12 plus 9. 12 plus 21, that is 33. Okay, so this 21 go on other side. 9 plus 2 is 11. 11i2 becomes 33, which implies that i2 is equal to 3. Okay, very simple. So i2, we have gotten the value of i2 from this equation. Now we can find the value of i1 if that's what has been asked in the question. And of course, once we know i1, that it becomes trivial to find the value of i3. Okay, from this equation we can find the value of i3. So all of those values can now be known. The number of steps in this problem is not too many. Okay, you might be scared about the number of steps, but all of these steps, if you write each step in maybe 2 to 3 seconds also, then you should be able to solve this problem in these many steps in under a minute, provided that you have solved enough problems, you have gained the accuracy, and you have the confidence. Okay, that is the most important thing. Let's move on to the next example. This example is slightly tricky. Why? Because here I have not simplified the circuit. So the very first step, where we try to simplify the circuit by using the parallel and series combination, that is to be done here, that is left to be done here, and we'll just do it right now. So in these two resistors, 5 ohm and 1 ohm, same current is flowing. So we know that they can be combined together to form a 6 ohm resistance. Okay, so that is what we would now use in writing our loop equations. Similarly, this 3 ohm and 1 ohm, same current is flowing. So these two can also be combined to actually form a 4 ohm resistance. So we'll just cancel out this. So we don't think there is a resistance here. We have combined it with this one. And similarly, this 5 ohm and 6 ohm resistance can be combined, and we now have a 6 ohm resistance. And that is what we will assume to solve rest of the problem. Other things would actually come very, very naturally. They'll come very, very easily. So now, here again we'll try to assign the currents. That's the, of course, our first step. And here what I do is that I choose the current from here to be I1. I can choose it any which way I want. So current here is flowing, which is I1. It is being divided into two parts, I2 and I3. So current flowing here is I3. Okay, you can choose any other way you want. Again, the first equation, this comes out to be I1 is equal to I2 plus I3. From this node right here, from this node I can write this equation, I1 is equal to I2 plus I3. There are three currents. Again, I need three equations. Now what I do is that in this case the loops I have chosen are such that I would choose this loop, because this looks simple. There is only 1, 2 and 3 elements. So I will choose this loop. This will be one of my loops. Okay, so I'll choose this loops and I'll traverse it in this direction. I'm already telling you. The second loop, I'm not choosing this because there are two batteries here. It looks slightly more complicated, so I don't want to go there. What I'll do is that I have chosen this larger loop right here. Okay, so I will traverse it in this direction. I will draw it with another color so that it is clear that we are traversing this larger loop, the outside loop. Okay, so that is what we will be doing, and I'm telling you the direction also. Okay, so that is my second loop. Okay, so these two loops would give me two equations, which I am writing just now. Okay, so let's just start with this one. So this I3, there is a this I2 is going like this, and we are going in the direction of current across this 8 ohm resistor. So this becomes minus 8 I2, and then we come to this 4 volt battery which we are going from minus to plus. So this becomes plus, and then this resistance, this I3 current is going downwards and we are going upwards. So we are going opposite to the direction of current. So here again we will add. So this is not a voltage drop but a voltage increase going from here to here, and this 5 plus 1 became 6 already. So I'm writing 6 ohm multiplied by this I3, and that is the potential gain when I traverse this equivalent resistance of 6 ohm right here, and this is equal to 0. We can simplify this equation a little bit. See, normally what we do is that we simplify the equations in such a way that the constant is on one side. Okay, that is what we do, and we do it because things become very, very simple if this constant is on one side. So what I do now is I take this, I keep it as minus 4i2, and I'm dividing everything by 2. So this 8 will become a 4, this 4 will become a 2, and this 6 will become a 3, plus 3i3 is equal to minus 2. Don't be afraid of that minus 2 there. That minus 2 is fine. Don't worry about it. Now the second equation we will write is the larger equation. I told you that. Okay. So now the larger equation also is not very difficult. It is simple only. So the first resistance we encounter is this equivalent resistance of 4 ohm with a I1 current. We are going in the same direction as the current. So there is a this one becomes minus 4 I1. So this is minus 4 I1, and then the current becomes I2, which is fine. We are still traversing the loop, and this 8 ohm resistor, we are going again in the direction of the current I2. So this becomes minus 8 I2, and notice that there are no more resistances. The only thing which we encounter is this battery, which we are going from minus to plus. So this becomes a plus 12 is equal to 0. See, I told you this will turn out to be simple. This equation would be simpler, and that is indeed the case. You have to just see which loop will give you minimum number of elements to traverse. Okay, why waste so much more time? So now again we divide everything by 2. So we are dividing everything by 2, and this becomes 2i1, and this becomes 4i2, and this becomes 6/12. Okay, so this becomes minus 2i1, and this will we change this sign right here, plus 4i2 is equal to 6. Okay, so that's the second equation. So now we have our three equations and three unknowns, and we have to solve for that. Okay, so this equation looks very, very simple. This one, 2i1, this particular equation. So what we'll do is that actually what I can do, I just noticed, is that I can simplify it further. So we'll just divide it by 4. So this becomes 2 and this becomes a 3. So this becomes I1 plus 2I2 is equal to 3. Now I1 I know is I2 plus I3. So this I can write as I2 plus I3 plus 2I2 is equal to 3. Now this becomes 3I2 plus I3 is equal to 3. So now I have two equations in I2 and I3. So here also I have I2 and I3. I have two equations both in I2 and I3. So from here I can now solve for I2 or I3. So if you start solving, so the easiest way to solve this would be actually to multiply this entire equation by 3 and subtract it from here, from this equation. We can do it. This becomes 9I2 plus 3I3 is equal to 9, and I subtract it from this one. Okay, so this becomes, so this is equation, let's just call this equation number 1, that was 1, this is became 2, and this we'll call it equation number 3. And so now what I am doing is I am doing 2 minus 3. That's what I am doing. Okay, equation 2 minus equation 3. So this is minus 4I2, and this is also subtracting, so minus 9. 9 plus 4 is minus 13I2. Okay, that is simple only. This 3I3 and 3I3 would get cancelled, and this is minus 2 and this is minus 9, and this will become minus 11. So from here I can quickly get the value of I2 as 11 upon 13. Okay, so we were able to quickly solve this problem. This was not very difficult problem to solve. We didn't even have to do that much maths. Okay, so once we have the value of I2, I can now use this equation to find the value of I3, and then I can then use this equation to find the value of I1. Okay, so very, very simply we can do back substitutions and find the other values. So with this we complete this lecture. In the subsequent classes we will be discussing shortcut methods. Okay, see, the Kirchhoff current law and voltage law are very powerful. We can always use those to solve any circuit equations, but the trick is to not actually use these because these lead to many equations which are difficult to solve. So we will be discussing the nodal method, the mesh method, and the star delta transformations to understand and to solve the circuit problems very, very quickly, much more quickly than what we could do with KCL and KVL. Thank you.